Hello students, here we start with the next session of probability distributions. In the last session we saw what is random variable, probability distributions, discrete random variable, its probability mass function, continuous random variable and its probability density function. In the first module we deal with discrete probability distributions. Among discrete probability distributions, we studied two main probability distributions. One is binomial distribution and the second one is Poisson distribution. We will start with binomial distribution. Binomial distribution. For this, we want to know what is Bernoulli's experiment. Bernoulli's experiment means it's a random experiment. It satisfies these four assumptions. First assumption is there are only two possible outcomes. It may be either success or failure. The second one is the probability of occurring success for each trial is same, or probability of occurring failure for each success is same. Number of trial must be finite. That is, we can take it as n, and the n trials must be linearly independent. Bernoulli's experiment satisfy these four conditions. Then consider a Bernoulli's experiment repeating n times. And in each trial there are only two possible outcomes. We are considering a Bernoulli's experiment and we repeat the process for n times. For the n times there are only two possible outcomes. It is either success or failure. Let P denote the probability that the outcome is success and let Q denote the probability that the outcome is failure. Then what will be the value of Q? We know that the total probability is always 1. We studied in discrete random variable the probability mass function sigma f of x is equal to 1. Therefore, if the probability of success is P, then probability of failure denoted by Q, its value must be equal to 1 minus P. That is, P plus Q must be equal to 1. The total probability must be equal to 1. Then, suppose there are out of n trials, suppose there are x successes. Then the probability of success will be equal to, out of x successes, the probability of success is p raised to x. Similarly, probability of failure is q raised to, what will be the probability of failure? See, out of n outcome x success, the remaining number is n minus x. Therefore, probability of failure is q raised to n minus x. See, these x successes can be happen from n trials in n cx different ways. There are total n trials. Out of this, there are x successes. The x successes can be happen in n cx different ways. Therefore, the probability of occurring x successes and n minus x failures out of n trials is, in total it will be n cx p raised to x q raised to n minus x. It is usually denoted by b x n p. It is known as binomial, or it is also known as Bernoulli's distribution. Bx and p is equal to n cx p raised to x q raised to n minus x. Here the values of n, since it is a discrete probability distribution, the values of n must be 0, 1 to etc. up to 0, 1 to etc. up to n. And here p and p is also a parameter. So a discrete random variable x is said to follow a binomial distribution if its probability mass function is given by f of x equal to n c x p raised to x q raised to n minus x. N equal to 0, 1 to etc. up to n, x equal to 0, 1 to etc. up to n, and q equal to 1 minus p. If x follows a binomial distribution, we denote it as x follows b x n p. It denotes binomial distribution. If a random variable follows binomial distribution, it is denoted as x follows. It is read as x follows b x n p. Here n and p are parameters. Next one is mean of binomial distribution. Suppose random variable x follows the binomial distribution b x n p. Then f of x equal to b f of x equal to its probability distribution is n c x p raised to x q raised to n minus x. We studied in the last class what is mean. Mean is denoted as expectation of x. It is equal to sigma x equal to 0 to n x into f of x, which is equal to sigma x equal to 0 to n x into, here f of x is this one, n c x p raised to x q raised to n minus x, which is equal to sigma x equal to 0 to n x into n c x can be written as n factorial by x factorial into n minus x factorial. P raised to x, q raised to n minus x, which is equal to sigma x equal to, see we can cancel x and x factorial here. The remaining term will be x minus 1 factorial. Since the denominator is x minus 1, the value must start from x equal to 1, since negative factorial is not defined. X equal to 1 to n factorial p raised to x q raised to n minus x divided by x minus 1 factorial into n minus x factorial. Okay, in the next step, we are rearranging these terms. It is equal to sigma x equal to 1 to n. This n factorial can be written as n into n minus 1 factorial. Then p raised to x is p into p raised to x minus 1. Q raised to n minus x is q raised to n minus 1 minus x minus 1. By simplifying this term, we get q raised to n minus x divided by, the denominator also it's already in the form x minus 1 factorial. Then n minus x factorial can be written as n minus 1 minus x minus 1 factorial. Okay. Then we can take the constant outside from the sigma notation. The sigma is in terms of x. So here the n, p, they are constant. N into p into sigma. Then the remaining terms, see, there are n minus 1, x minus 1. To simplify it, substitute n minus 1 equal to m and x minus 1 equal to y. Then it becomes x minus 1 equal to y, then x equal to 1 becomes, x equal to 1 means x minus 1 equal to 0. That is y equal to 0 to n. 0 to m. Instead of n, we should use m. Then n minus 1 factorial is m factorial divided by x minus 1 y factorial into m minus y factorial into p raised to y q raised to m minus y, which is equal to n into p sigma y equal to 0 to m. This term can be written as mcy p raised to y q raised to m minus y. It's equal to np into, it's the binomial distribution. The total binomial distribution sigma is 1. Therefore, its mean is n into p. Similarly, we can prove the variance of binomial distribution. Variance of binomial distribution. Variance, the general formula for variance is variance of x is equal to expectation of x square minus expectation of x the whole square. Expectation of x, we already found it, the mean, it is np. Therefore, we want to calculate this one, expectation of x square. To calculate the same, rearrange the term x square as x into x minus 1 plus x. By the properties, it is expectation of x into x minus 1 plus expectation of x. Then calculate expectation of x into x minus 1. Expectation of x into x minus 1 is equal to sigma x equal to 0 to n x into x minus 1 into f of x. Then as in the case of mean of the binomial distribution, simplify this and solve. Please try it by yourself.